Hi everyone, so here we are going to start with numerical solution for class 9 physics for St. Thomas School, Ranchi. And here we are going to see chapter number 2, motion in one dimension, exercise 2a. And here we are going to see the numericals related to motion. So here we have the first numerical. A car travels first 30 km with a uniform speed of 60 km. And then next 30 km with a uniform speed of 40 km. Calculate total time and average speed of car. So in this question it means that there is one car which travels first 30 km with 60 km per hour and next 30 km with 40 km per hour. Then we have to find the total time taken by the car to come while completing his journey and the average speed of the car while completing its journey. So here we are going to see the solution. So according to the question, so A to B and B to C, we have taken this distance. So first 30 km from A to B in 60 with a speed of 60 km per hour. Next 30 km from B to C with a speed of 40 km per hour. So we are going to complete how much time the car has taken to cover a distance from A to B. So this is the time 1, distance by speed. The time 1 is 0.5 hours. Then next time 2 we are going to find out from the distance B to C, and then the time 2 is 0.75 hours. Then the total time taken by the car to cover distance from A to B and B to C we are going to add, and it is 75 minutes or 1.25 hours. Then to find out the average speed, we know the formula total distance by total time. So total distance here we have 30 km plus 30 km in a question, and then total time is 1.25 hours. So therefore average speed is equal to total distance by total time, and we got the answer as 48 km per hour. So we found out total time taken by the car, which is 1.25 hour, and total speed and the average speed of a car, which is 48 km per hour. And then the next, so next we are going, here we have a numerical. A train takes 2 hours to reach station B from station A, and then 3 hours to returns from station B to A. Then in that case we have to find out its average speed and average velocity of a car, and the distance between the two stations is 60 km. So we are observing here station A and station B. So it takes 2 hours to go from A to B and 3 hours to return from B to A station, and the distance between two stations is 200 km. So total distance total distance traveled by the train will be 200 plus 200, that is 400 km, and total time as it is given here 2 hours while going and 3 hours while returning. So total time we got it as 5, and total distance 200 plus 200, which is 400. So we are going to get average speed total distance by time is equal to 80 km per hour, and then we have to find out the average velocity. Average velocity becomes 0. Why? Because velocity is the total displacement by total time. So when the train returns back to station A means the displacement is 0. So therefore average velocity becomes 0. In the next numerical now, A body starts from rest and acquires a velocity 10 meter per second in 2 seconds. Then find the acceleration. So here we are going to find out the acceleration. What it is given here, the body starts from rest. So when the body is going to start from rest, it means that its initial velocity is 0 and it acquires a velocity of 10 meter per second in 2 seconds. So means that the final velocity of the bodies is going to be 10 meter per second and the time is 2 seconds. Then we are going to use the formula of acceleration, v minus u by t. V means final velocity, u means initial velocity, t is the time. So final velocity 10, initial velocity as it starts from rest, rest is 0 and time is 2. So after solving we are going to get acceleration is equal to 5 meter per second square. The next we are going to see the numerical. A body is moving vertically upward. Its velocity changes at constant rate from 50 meter per second to 20 meter per second in 3 seconds. What is its acceleration? So means that a body is moving in upward direction, then its velocity decreases from 50 meter per second to 20 meter per second in 3 seconds, and we have to calculate the acceleration of the body. So means that its initial velocity is 50 meter per second, final velocity after 3 seconds is 20 meter per second and time is 3 seconds. So again we are going to use the formula of acceleration, v minus u by t. V means final velocity, u means initial velocity and t is the time. So final velocity 20, initial velocity 50 and time is 3 seconds. So here we are going to get the acceleration in minus, which is minus 30 by 3, means acceleration is equal to minus 10 meter per second square. So this means that this acceleration, as it is in negative direction, so we can say it is a retardation. So retardation is equal to 10 meter per second square because its velocity decreases from maximum to minimum. So therefore body is in retardation motion. In the next numerical we are going to see a car accelerate at a rate of 5 meter per second square. Then find the increase in its velocity in 2 seconds. So means that acceleration is given and the time is given and you have to find out change in velocity. So to find change in velocity, again we are going to use the formula of acceleration, a is equal to v minus u by t. So v minus u can be also written as change in velocity by time. So therefore change in velocity is equal to a into t. So therefore change in velocity, a is given, that means a is acceleration and t is time. So acceleration is 5 and time is 2, so 10 meter per second. So means that change in velocity or increase in its velocity is 10 meter per second. So next we are going to see the numerical. A car is moving in a straight with a speed 10 km per hour. It is stopped in 5 seconds by applying the brake. Find speed of a car in meter per second, retardation and the speed of the car after 2 seconds of applying the brake. So means that a car is moving in a straight path with a speed of 18 km per hour and then brake is applied to a car and after 5 seconds car stops. So means that initially the car is moving with 18 km per hour and then the brake is applied and car stops after 5 seconds. and then we have to find out what is the speed of the car and the retardation which is going to occur because its velocity decreases, and then what is the speed after 2 seconds. The solution is here. So we are going to see the solution. So initial velocity is 18 km per hour. We are going to convert 18 km per hour to initial velocity 18 km per hour. We have converted 18 km per hour to meter per second. This is the first solution. The speed of the car is 5 meter per second. And what it is given here, that when the brake is applied, car is going to stop. So means that its final velocity becomes 0 and car stops after 5 seconds. So this means that after applying a brake, its final velocity becomes 0 after 5 seconds. So now for this we are going to find out the acceleration by using formula v minus u by t. So final velocity becomes 0, u is 5 meter per second and time is 5. So then again, as it is a retardation, we are going to get the answer in negative. So acceleration is minus 1 meter per second square, or retardation 1 meter per second square. Then next in the question we have to find out what is the speed of the car after 2 seconds. To find out this, what is its speed after 2 seconds, again we are going to use the formula a is equal to v minus u by t. So a means acceleration, we have already found, which is minus 1 meter per second square. V we have to find out, means after 2 seconds what is its velocity. So this v we have to find out, and initial velocity we know it is 5 meter per second square, and time as we have to find out after 2 seconds, so time is 2. So after solving the value for the v, we got the answer as 3 meter per second. This means that after 2 seconds the velocity of the car after applying brake was 3 meter per second. So under this all numericals, what we have seen in first numerical we have seen so in first numerical we have found out average speed of a car by using formula. In first numerical we have found out average speed by using formula total distance by total time. And then in second numerical we have found out average speed by using formula total distance by total time. And then also we have understood that as the train returns back to its original position, displacement becomes 0 and then average velocity becomes 0. Second numerical we found out average speed and average velocity. Then in third numerical we have found out acceleration, v minus u by t. And then in fourth numerical we have seen it is how to find out the retardation, means minus acceleration. So when the acceleration is going to come in negative, we can say that it is a retardation. Then the next numerical we have seen, again we have found out change in velocity with the help of formula a is equal to v minus u by t. So v minus u is also called as change in velocity. So in this numerical we have learned to find out how to find change in velocity. Then the last numerical we have found out what is the acceleration of that object. As it is in negative, then it is called as retardation. And then again after 2 seconds, how to find out the speed of any object, means if an object is in a motion, how to find any speed in between when the brake is going to apply. So this is all about the numericals related to acceleration. Thank you.